2. Before you can solve a quadratic equation using the quadratic formula, what do you have to do first? Right, you have to get it equal to 0, which means get it put in standard form. Standard form of a quadratic equation is ax squared plus bx plus c equals 0. Well, why is number 2 not in standard form? Correct. This belongs over here. And since it's a negative 6, to get it to go over there, how do you do it? Correct. Okay, so now you have 6x squared plus 6x plus 6 equals 0. Now it's in standard form, so I'm ready to do the quadratic formula. I'm going to write the quadratic formula over here. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. But to be able to use that, we now need to identify what the a, b, and c are. What is the a for this one, D'Orlando? What is the a value? Right. What's the b value? And what's the c value? Right. So now, guys, there's too much talking. I'm going to rewrite the formula, the quadratic formula, but I'm leaving blanks for everywhere that I'm about to plug something in. Okay. So the first number I need to plug in is the b values. There's 2 b values in the formula, and what goes in those places? Right. What goes in the a places? And what goes in the c? Right. Now I'm going to make myself some scratch paper because I'm running out of room. What did I tell you you need to simplify first? The discriminant. Everything up under the radical is called the discriminant. So go ahead and type that in. And what do you get? Negative 108. And then over what? 12. So at this point, I'm going to go ahead and break it apart and put the 12 underneath each part. Okay. Can the square root of 108 be simplified as a radical? Is it a perfect square? How do you know if it's a perfect square or not? Well, you type it in. So if I type in the square root of 108, it does not give me a whole number. That means it's not a perfect square. So I need to try to think of numbers that multiply to 108. Well, if you're having trouble, you notice right away 108 is even, so you can start by dividing it by 2 if you don't know anything else. Or you can do many other options. 12 and 9 works. Okay? So 12 times 9. 12 breaks down into 9 breaks down into, and then can we break anything else down? Cameron, you're about to have a new seat. Okay, so we have a set of 3s, a set of 2s. So what's the only thing that goes back inside? 3. And then so how many get kicked out? Well, a 2 and a 3, which is 6. Now you have to keep in mind, since it was negative, you have to put an I. Okay, now I'm going to just bring down the rest of the stuff. Negative 6 over 12 plus or minus 6i squared to 3 over 12. Do you think that's the answer you will see on the test? No, because you can reduce this. What's negative 6 over 12 reduced to? Negative 1/2. And then plus or minus, there's another 6 over 12. So that's 1i squared to 3 over 2. You don't have to write that one. And that's the final answer. Now, let me show you what the graph would look like. I'll go back, don't worry. 6x squared plus 6x plus 6. If I graph that, does it cross the x-axis at all? No. That's why you end up getting an answer that's complex with an I. Does that make sense? Okay, go ahead and get a head start on number 4. Everybody start on number 4. Shh. Now, 4. Here we go. Step 1. What's step 1, Grant? Shh. Grant, what's step 1? Right. We need to move this C value to the other side. So we add it on both sides. And you get 6v squared plus 5v plus 5 equals 0. Now that it's in standard form, what's step 2? Anybody, step 2. Right. Label. Shh.
Shut up.
Label A, B, and C. Shh. What's A? What's B? And what's C? Now that we have A, B, and C identified, step 3 is plug it in the formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we just plug them in where they go. This and this are b's, so that will be 5's. This one and this one are a's, so those will be 6. And then this one is a 5, C. Now the first thing you simplify is the discriminant. So x equals, that negative just attaches to the 5, plus or minus the square root of what? What is the discriminant here? It's 25 minus something, whatever 24 times 5 is. Negative 95, okay. Okay, but then that becomes a 12, and I'm going to go ahead and break it apart and write it under both. Now, so somewhere to the side, you have to see if you can factor tree 95, because it's not a perfect square. What are factors of 95? 5 and what? Okay, but then we run into a problem, because aren't both of those prime? So there's nothing that can be circled. That means everything goes back in the house. So 95 can't be simplified. So you just leave it as negative 5 over 12, because that won't reduce, plus or minus. You do have to take the negative out and make it an I on the outside, and then over 12, and then that's the answer. Does that make sense? Okay, go ahead and get a head start on number 6. Okay. Micaiah, what do I do first? Right. Shh, there's too much talking. Okay, then I have 6n squared minus 9n plus 7. Kiara Watson, what do I do next? Right. Right. Once you have that, okay, I'm just writing out the whole thing first. B squared minus 4ac over 2 times a. Okay, so now what goes here? Negative 9. Okay, let me stop and say something. I highly recommend writing it out just like I do, like writing out the formula but leaving all the blanks, because I know that there are some of you who will end up leaving this negative otherwise, because you'll forget that there was a negative in the formula and your B was negative, which becomes a positive if you don't already have the formula written out before you start. Okay, it happens all the time, I promise. If you go ahead and write out the formula, then you plug in your numbers, it'll be obvious that you have two negatives that make a positive. Okay, we also put a negative 9 here. What do we put in the A places? And what do we put in the C place? Right. Kiara Watson, what do I always tell you to simplify first? Right, what's under the radical, which is called the discriminant. So this I can go ahead and write as a positive 9. And then what did y'all get up under the radical for the discriminant? Negative 87. And then what does the denominator become?
12.
I'm going to go ahead and break that apart. Shh. Okay, now I see that 9 over 12 will reduce to what?
3 over 4.
Right, so I'm done with that part. Now let's look at the complex part. 87 is not a perfect square, but can you factor tree it?
No.
What are the factors? 29? Okay, but then 29, does it break down? Are the only things to make it 29, 29, and 1? So it's prime. That means 87 does not come out of the radical. It can't be simplified, but the negative does as an I and then over 12. And that's the final answer. Okay, number 8. I'm going to do 8 and 10 quick because we got to move on to the next thing. This one? Yeah, we already did that part. Well, but then 29 doesn't break down, so everything would go back in. Oh, no, no. This is an inside number because it's inside the house, and that's outside, so you can't do those. Okay, here we go. Number 8. Shh. What's step 1? Right, move the 9m over there by subtraction. So now we have 10m squared minus 9m plus 10 equals 0. Once it's in standard form, the next step is identify your A, B, and C. 10, negative 9, and positive 10. Once you've identified your A, B, and C, write out the formula ahead of time. Just leave blanks for what you're going to plug in. I know that seems like extra work to you, but you'll be more likely to get it right. Hold on. Okay, so now that it's written out, I know both of these are B's, so both of those are going to have a negative 9. Both of these are A's, so they're both going to have a 10. And then C is also 10. Once you've done that, I could go ahead right away and make this negative 9 a positive 9. I can simplify the discriminant. Go ahead and type in the discriminant. Negative 319. Yeah. And then I can go and multiply the denominator, which gives me a 20, and I'm going to write it under each part. That way I can look and see if it reduces. I see that the real number, 9 over 20, will not reduce, so it's going to stay 9 over 20. Is the square root of 319 a perfect square? Okay, how do you check? Don't you just type it in to see? It's not, which means we need to try to factor tree it. So somewhere to the side, what are the factors of 319? 29 and 11? Okay, but aren't both of those numbers prime? Okay, so that means that you cannot reduce that. It's as simple as you can get it. So you leave it in the house, but the negative becomes an I, and you put 20 underneath. Who can tell me why we only type in the discriminant and not the actual radical too when we type it in the calculator? Right, because if it's a negative number, it'll give you an error. Even if it were positive, it's not going to give you the answer in radical form. It's going to give you the answer in decimal form, and then you wouldn't be able to reduce the fractions. That's why you have to reduce it in radical form. Okay, so that's the final answer. Now let's look at number 10, and then we're moving on. Everybody got it? All right, number 10. Okay, the first thing I need to do is get it in standard form. That means this C needs to go to this side. So that will become 12n squared minus 2n minus 7 or plus 7? Minus, because it was already positive. Once you have it in standard form, you identify the A, B, and C. Right? Then you set up your formula. Okay, hold on. First I'm going to write out the formula. Because I don't like to make mistakes. Alright, these are both B values, so we put negative 2 in both of those. These are both A values, so 12 goes in both of those. Stop. And this is C, so that's negative 7. A negative 2 becomes a positive 2. Plus or minus the square root of what? 340? Over what? Shh. 24. Okay, now I can go ahead and reduce that fraction. What is 2 over 24 reduced to? 1 over 12. Plus or minus. Is the square root of 340 a perfect square? No. So we take it to the side and we reduce it in radical form. What numbers multiply to give me 340?
Do another bond.
20 and... Okay, 17's prime. So 5, 2, 2, and 17. So kill 1, kick 1, 2 out. And then 17 and 5 go back inside, which is what? You multiply. 85, and then over 24 still. So now can I go one more step? Because now that right fraction can also simplify to 1/12, but you don't have to write the 1 on top, just on bottom. So there's the final answer. Once you've copied that, go ahead and flip to page 9. No, that's 1/12. Look, 2/24 reduced to 1/12. But it's understood, you don't have to write it. Okay, I'm moving on. Okay, today we're going to start learning another way to solve a quadratic equation. Shh, listen. Now, this equation could also be solved using the quadratic formula. This particular one could also be solved using factoring. However, today we're going to learn a third way to solve it. It's called complete the square. So, step 1 is use ax squared plus bx equals c form. So today, with complete the square, you want the c to be on the right side. So if we do step 1 to this quadratic equation, what will it need to look like? Equals positive 21, because to move it over to the right side, we need to add it over. Any questions about step 1? Okay, to use complete the square to solve, you have to get the c on the right. The constant goes on the right. Step 2, you're going to add blanks to both sides. Yep, just another way. However, you are going to be tested over it on the test, and it won't be a case where you could just use another way. Like, they're going to make sure you know how to do this. Okay, step 2, so that means just take x squared plus 4x, and then add a blank to this side, and we're going to fill in that blank in the next step, and then 21 plus blank. Okay, you're going to use the formula b divided by 2 squared to fill the blanks. And I'm having to skip words just to fit everything. Okay, you're using the formula b over 2 squared to fill in the blanks. Okay, so in that quadratic equation, what is the b value? Well, just 4, right? If you divide that by 2, you get a, and if you square that, you get a. That's what you're going to put in the blank on each side. Okay, step 4, you're going to factor the left side. Okay, you're going to factor the left side. And then combine the right side. Okay, so if I'm trying to factor this trinomial, I'm just going to write 2 factors, and those 2 factors have to make this. They have to multiply to 4 and add to 4. What numbers will do that? A positive 2 and a positive 2, right? Because 2 times 2 is 4, but 2 plus 2 is also 4, and then of course you have to have an x in each one to make that x squared. On the right side, you're just going to combine them. 21 plus 4 is 25. Alright, step 5. You're going to write the left side as a binomial squared. Okay, you're going to write the left side as a binomial squared. that means is since there's two x plus 2's, instead of writing it twice, couldn't you just write it once and square it? Okay, step 6, you're going to take the square root of both sides. Okay, so like if I take the square root of the left side, doesn't that square root cancel out the power of 2 because they're inverse operations, leaving just x plus 2 because those two things cancel each other out? If I square root the right side, what do I get? 5. Okay, but remember how we talked about when you're solving for x and you have to take the square root? What goes on your answer? A plus or minus. Because think about it, isn't a positive 5 squared a 25? But isn't a negative 5 squared also a positive 25? That's why you have to put that plus or minus. So you're going to simplify and don't forget plus or minus. Okay, then you're going to subtract to solve for x. Just think about it. If you're trying to solve for this x, wouldn't you subtract this 2 on both sides? Well, you have a positive 5 that you're subtracting the 2 from, but you also have a negative 5 that you're subtracting the 2 from. So then just remember there are 2 answers. Now the reason there are 2 answers is because this is a quadratic equation. It's degree 2. When your highest exponent is a 2, that means you'll have 2 answers. So if we were dealing with something with the highest exponent of 3, we would have 3 answers. What are the 2 answers? The first one is 5 minus 2, which is 3. The second one is negative 5 minus 2, which is negative 7. Okay, now let's graph this, and I'll show you why you end up with 3 and negative 7. If I quickly graph it, x squared plus 4x minus 21. When I graph it, it crosses the x-axis in 2 places, and aren't those places a positive 3 and a negative 7? Okay, let me show you something else. Well, I'm just going to do it up here. This is just added stuff. If I looked at this and say I had never learned quadratic formula and I had never learned complete the square, I could have solved this one by factoring. You could have done the bubble method and found 2 numbers that multiplied to negative 21 and added to 4. So multiply to get a negative, don't you need 2 different signs? If you had done a positive 7 and a negative 3, wouldn't that have multiplied to negative 21 and added to positive 4? But then remember, that's just factored. To solve it like we did the other day, didn't we set each one to 0? And then like you would have subtracted the 7 and got negative 7, and you would have added the 3 and got positive 3. The reason, though, that you're having to learn this way to do it, even though you could have done it that way, is because they're testing that you learn this concept. And they're going to ask it on the test in a way where you can't just solve it another way. You can't just factor, you can't just quadratic formula it, even though we all know we can get the answers that way. They're going to ask it on the test, like what would be the next step if you were completing the square. So you have to learn this process. You're not going to be able to just solve it in a different way and get the right answer. Does that make sense? Okay, this is what I want you to try for homework. 1, 2, and 3. You have crystal clear steps right here, so if you follow them, you should be able to try 1, 2, and 3. Okay? If you try it, you'll be much better off tomorrow than people who don't try them.
You got a kiss.